The jet engine changed everything. Where a propeller converts engine torque into thrust mechanically, a jet engine generates thrust directly, compressing incoming air, mixing it with fuel, igniting the mixture, and expelling the exhaust at a high velocity through a nozzle in a continuous cycle that produces forces no propeller-driven aircraft could match at speed. The result was a doubling of practical aircraft speeds within a decade of the jet's introduction in the 1940s and the opening of the entire supersonic flight regime that propeller aircraft could not physically enter. The Boeing 707 cut transatlantic crossing times in half when it entered service in 1958, and the commercial jet airliner it represented has been the backbone of global air travel ever since. The Boeing 737, the Airbus A320, the Boeing 777, the Airbus A380, carrying hundreds of passengers between cities on every continent, every hour of every day. Every commercial flight most people have ever taken has been on a jet. Every long-haul route connecting continents depends on jet engines producing the thrust required to sustain a fully loaded aircraft across thousands of kilometers of ocean. At the extreme end of the same category, the Concorde sustained Mach 2 in commercial passenger service for 27 years, and the SR-71 Blackbird cruised at Mach 3.32, where its standard response to a surface-to-air missile launch was simply to accelerate. Both are jet aircraft, both using the same fundamental propulsion principle as the Boeing 737 carrying 180 passengers between regional airports. The breadth of what a jet engine makes possible, from the most ordinary flight a person is likely to take to the fastest sustained manned flight in history, is the measure of how completely the technology transformed aviation.